Welcome to the IoT Podcast, the home of IoT talks and tells. I'm your host this week, Brad King-Taylor. Tune in every Monday as we are joined by the biggest names in IoT to unravel the trends, misconceptions and predictions for the Internet of Things. Make sure you're subscribed and press the notification bell so you're never out of the loop.
Hi guys, before we get into the episode today, I wanted to give a shout out to our sponsor, Akenza.io. Akenza.io are a self-service IoT platform allowing you to build great IoT products and services with real value.
Okay, so obviously we are delighted to have you, Ashish, and welcome to the podcast. I think always the best place to start is an introduction to yourself, Ashish. So if you could say hello to everybody and give us a little bit of a background on your journey and how you got to where you are now.
Sure, Brad. Thank you very much, and good morning. It's not been a bad morning; just been a light drizzle to work, and but it's been an interesting journey all the way along. So I was born in India, did electrical engineering, and life was meant to be more of electrical engineering because my family has a bunch of electrical engineers and scientists who thought electrical was the best form of engineering. But I think I had other ideas, and we wanted to look at AI in my final year of my project, and we were looking at aspects of fuzzy logic for control systems. That got me interested massively into artificial intelligence back in 1997. So seems like a lifetime ago. And I then chose to go to Germany to study computational logic, which is basically everything that is foundational to formal methods. And from that point onwards, my life changed, and I decided to become a fan of formal. And that's pretty much what I've been doing for the last, 2 decades plus. And so started Axiomise. 5.5 years ago now. Time is moving fast, and you know, long story short, it's a lot of fun. Had a good chance to move between continents, which is not something I think everybody gets a chance to do. So from India to Germany, then from Germany to Scotland. My PhD supervisor was in Scotland at the time, and we were there for about 2 years, and then he had an offer from Oxford, and he said, "You want to come along?" And it was hard to say no.
Yeah.
So I moved to Oxford, and then in the middle of my PhD work, had a chance to go and work with Intel in the US. So again, then come back, and then about 12 years ago, I decided to relocate to Bangalore, and I moved my whole family over to Bangalore, and then um, we lasted there for a year and then came back to the UK.
Nice.
Lovely weather here, so just great.
Well, sometimes, right? Sometimes we're apparently meant to be coming into the spring, but I'm yet to feel that sort of thing. I'm just intrigued. You mentioned that in 1997 you started off and were really intrigued on AI. If you were to sum it up in a couple of sentences, what's the difference between AI in 1997 and AI now?
So I'll tell you the biggest event of this is I had an offer to do PhD in machine learning and AI in the year 2000 when I finished my master's, and nobody believed in AI. People thought AI was dead because there was one half which was logicians. A lot of the work that we do in formal also comes from AI, and then you had people doing neural networks. My master's thesis was in combining neural networks and logic, something called symbolic AI. Wasn't even known that much in those times. And now I see IBM pioneering symbolic AI in 2023. And now if you're not using the word AI and ML, then you're not even trendy or vogue anymore, right?
Yeah.
It's really that contrast. When I started to do formal methods, formal was very hot at the time because of some events that had happened 4 or 5 years earlier, which meant that the chip design makers, the big ones, were looking at formal methods more seriously, or just beginning to look more seriously, let's say. And as I said, AI was, not much in fashion was
Yeah.
pretty much dead, really, other than academic papers. But now look around us, it's everywhere.
It's everywhere. Yeah, and that's the reason why I wanted to. I know it wasn't in the script, if you like, but when you mentioned the AI in 1970, I was just so intrigued because it has become massive now. Like you said,
Oh, it
it's
is.
just a
It
day.
is.
It's just
It
in
is.
the life of everybody, isn't it? So,
And I think the main difference is previously a lot of the AI was done in software, uh, and now with a lot more of the work done at hardware level to make decisions faster, um, and do it in the way to save power, high performance compute on the edge. This has just taken a completely new role. And if you now look at the ecosystem of listening devices around in the house and in our pockets and whatnot, um, it's just crazy how much AI now knows us than even us knowing us.
yeah, it's
It's,
madness. Anyway, we get sidetracked, so let's go back to yourself, Ashish. And you mentioned Axiomise and obviously formal. So, Axiomise, give us a bit of a background on where that came
yeah,
from, what the history is. How did
yeah.
you come to found it?
Yeah, so I was a graduate student in Germany, and then I did my PhD, and I had this really nice opportunity to work at Intel's strategic CAD labs as an intern, and my PhD was sponsored in part by Intel. So I was doing some really high-end problem reduction research work on hardware, and then when I left the university and went and did some postdoctoral research work, it was more of the formal work. But I realized that in 2010, 2006, about even as late as 2012, really, people were still trying to embrace formal, were still largely skeptical. And I had a lot of success in driving formal methods adoption and imagination. I was also one of the early people at ARM who were in the midst of deploying formal, and I think it made sense for me to do more of this at a wider scale. But then I had this opportunity to work with a German company where I spent 1.5 years, I would say, in an EDA role. So the developer of tools rather than the user of tools, which is what I
Yeah.
was. And a time came when I said to myself, I can do a much better job at making formal normal in the industry by actually having my own shop and go to the customers and actually solve the hardest problems that they need solving. And it cannot be done any other way, because if you are working for somebody else whose vision is not fully aligned, then it gets a lot harder. So one fine day, I just decided to open my own business. This was October 2017. I had a really well-paid job, good money coming in,
Yeah.
no complaints, and lovely company, the German company, OneSpin Solutions. But what was about to happen then, in the last 5.5 years, hasn't been a long time,
Yeah.
but in the life of a startup, it seems like a long time. And starting from nothing, grounds up, basically with no cash in the bank, with no customers, coming up with a vision that you want to make formal normal through software, through services, through training. Um, it's been a great 5 years. I've taught 200 plus people in the industry, some of the biggest names that you can think of. Their engineers have come in and told me that the training changed their lives. In one case, the manager phoned me back 8 months after the training to said, "This is the first chip that we are shipping, completely verified with formal. Thank you from the bottom of my
Nice.
heart for actually making it possible." And no amount of wealth can actually bring you that happiness when you hear that someone's life can be changed positively. So so that's what Xmice is all about. We are actually trying to change the way industry looks at formal verification, and it's not easy, because let's get this one right, it is a cultural change,
Yeah.
and it is going to take some time for people to appreciate. it is always harder than you think it is. that's
Yeah,
that's one of the things I learned.
absolutely. And I think, well, as you know, we do a lot of silicon work and GPU stuff, and formal comes up quite a lot. So let's just touch on formal, because you've mentioned it quite a lot, and I want to come back to the formal is normal phrase that you've mentioned a couple of times, because it's real catchy, but I want to understand a bit more about how you think we could get to that. So
Sure.
formal verification, then, how does it really differ to traditional verification, if you like?
Yeah, so traditionally, way before semiconductors or digital designs were even built, back in the days of mechanical, electrical, civil systems, the concept is you test something, you write something, you build something, and you want to see if it works. So what do? You test it under different scenarios, and you say, okay, what if I send this input? Do I see this output? That is effectively what simulation is. It is an input driven, fundamentally test based technique where you write a specific cases and check if the output has the expected behavior, which may be a behavior in your mind, and you could visually check on the screen to see if the results come back all right, or you could write a reference model which checks that the expected values match with with the actual design that is being tested. And entire software is built like that, and hardware has been tested and simulated. So simulation is quite a big dominant player in digital and analog verification. Um, the key is you supply the input stimulus, you then have a reference model, and you observe the equivalence of the reference model and the design that's being tested. Formal, on the other hand, works very differently. We provide requirements which are usually given by describing some English language requirements and turning them into precise mathematical logic properties. We use what is called temporal logic, language of system Verilog assertions and PSL. And effectively, what it does is it gives a very precise meaning to what we are intending to say in English. And the magic then happens is that formal tools do not need any stimulus. So these requirements then get analyzed on a mathematical representation of the design. So that is where the word model checking comes from. The model checking word, which is the old classical phrase from where property checking has been derived, is you have a model of the design that is being analyzed, checked for correctness against these properties or requirements. And this is done by actually doing a search. So, in a most primitive form, it is a search over the state space encoding of the hardware model, digital model. And in fact, this is why I was saying the roots are in AI, because the earliest algorithms were breadth first, depth first. These are variants of graph based search algorithms. But the beauty of modern day formal methods is that if these properties do not match with the model, then a failure is generated, which is basically a counterexample, and you can debug it and see what went wrong. But if the tool cannot find any failures, you get a mathematical proof, a proof that this particular behavior requirement property that you just checked is true on all the reachable set of states that the design can ever hit. This is a very, very strong statement of correctness.
Yeah,
I'll give you an example. If you're verifying a 64-bit counter, very, very simple toy design,
yeah,
in simulation, you would have to test 18 and a half quintillions simulation vectors to make sure that the counter is correct. Now, nobody in simulation would ever do that, and they would
yeah,
say, Ashish is crazy. We do the corner cases, um, representative ones, we do coverage. But that's fine for counter. Maybe you don't need it. Actually, I would say you do need it, because we have found bugs in a counter buried in a big SoC in a memory controller, where the counter overflowed around 2 to the power 31 value mark. So this counter was never tested exhaustively. Hey, why would you test it exhaustively? It's a counter, right?
yeah,
It's a small thing. And because it's a performance counter, the bug showed up in an emulation trace, because emulators are about 100x faster than simulators. And the bug was a really, student type bug, a new student to VHDL Verilog would make. But with formal, we could reproduce it in 1 second of runtime, not just for a 64-bit counter, but going all the way up to 512-bit counters.
Yeah, amazing.
I mean, we're talking about states and numbers that human beings can't even comprehend. And being able to say that actually, no matter where this is deployed, this will always be correct. So the power of being able to get a proof without driving any stimulus, just imagine this two combination, and getting a coverage on the entire state space is a powerful mechanism.
Yeah.
Every time I say this to somebody new, they say, why is it that people are not using more formal? But the problem is there is been a traditional gap in how people perceive formal. Some people came along and promised too much, could not deliver. And there are other factors at play. But, from a very technology point of view, these two techniques are fundamentally different.
Yeah.
And by the way, there are commonalities too. The way we build formal test benches roughly follows the same flow as how a simulation person would build a test bench. But we can do this on another day, Brad.
Yeah, we could go into that quite.
I could start my tutorial right here.
In depth. I suppose just for the sake of these, because there was a lot of differences, a lot of reasons why we back formal, for instance, compared to simulation, and then where we can take it. If I was to say to you and put you on the spot a little bit, Ashish, if you were to give us 3 words, because obviously simulation-based verification has been around for decades, right?
Forever,
for a long time.
Yeah.
If you were to say to me three key words on the difference between simulation or the benefits between formal and simulation, what would the 3 words be?
So one would be that you can get proofs with formal. You can't get it with simulation. There's zero stimulus to write with formal. There's tons of stimulus sequence generation in simulation. And you can find corner cases with formal with much shorter traces and debug them much more efficiently. So if you just wanted 3 keywords, remember proof, stimulus, and debug.
Perfect. Yeah.
Debug, by the way, is costing about 47% of the overall verification time. So you were saving all along. Sequence generation, test writing, test planning. Oh, I didn't even tell you about the verification report card. I should tell you about the report card generated by the Wilson Research Report from Harry Foster. And they have compiled a lot of data. I'll bring up some of these in a bit. But debug in particular and test writing and test planning are very expensive activities, both of which would benefit by not having to do simulation in places where you could do formal.
You mentioned a couple of times that there are some misconceptions, there are some challenges, or the way that people view formal can sometimes be a little bit, I don't want to say uneducated, but it's there, right? So in terms of you then, Ashish, what are you seeing as some of the challenges and misconceptions around formal verification?
So effectively what's happening is people are saying, look, to do formal well, you need a PhD. And actually, you don't need a PhD in formal. They're saying, look, formal needs specifications. Who really has specifications? We're busy building designs. We don't write specifications. The truth is that a lot of the bugs that escape the design are due to poorly formed requirements, misunderstood specifications. And it's not that specifications are only needed for formal, but people who are skeptical say, look, it would be a big overhead to try and create a fine list of specifications. Believe me or not, a lot of the bugs we catch in projects are because the specifications themselves are even incorrect or inconsistent. It's a natural artifact, nothing unique. The famous one is you can't scale formal to large designs. This is the most interesting one. So we have looked at formal on designs as big as 1.1 billion gates.
Massive.
That's massive. And I'm talking about functional verification, not connectivity checking. Then somebody would come along and say, well, we are interested in bugs. We're not interested in your proofs. So it's only useful for proofs. And not everybody, but some people would say that. Or someone will come along and say, formal is rather limited. It only finds corner case bugs.
Yeah.
And my point is, look, we can find your corner case bugs. We can find bugs that simulation would catch weeks and months later. We would catch them in week 1. We can build exhaustive proofs. Oh, you can't get coverage from formal is another nice one, right? So I recently wrote an article for electronic design called 11 Myths about formal, and some of these myths are described in detail with supporting evidence to say, show people what exactly I'm saying and why I'm saying that, more importantly.
Okay, so there's some misconceptions. There are some challenges. It seems like Ashish Axiomise and some of the papers that you mentioned, the 11 Myths one, which I'll look up and have a read of. There are some ways that we can overcome those. So, in your wisdom, if you like, Ashish, if you were to give some best practices and guidelines for
Mm-hmm.
people, particularly in the IoT space,
Mm-hmm.
what would be your advice of how to overcome some of these challenges or misconceptions?
Yeah, so I'll go into that. Let me actually tell you a few hard facts, right? So even you and I might be sold on formal, right? But um, the average simulation based verification engineer or his manager, they've spent 3 decades doing
Yeah.
simulation, right? So why even bother, right? Let me tell you 5 facts that I think are fairly important from the Wilson Research Report. And Harry Foster, chief scientist of Mentor, which is a Siemens business, summarized it. So 58% of the IC designs that end up in an ASIC and 49% of those that end up in FPGA are actually using security features in hardware that they consider necessary for verification. So it's not
Right.
like they're using security, but they need verification. If you are doing security verification, you need a technology as powerful as formal because you need assurances coming from proofs, and you need to harness this unique ability of formal that it can deal with unknowns and find you bizarre corner case scenarios that you would never be able to find very easily. Let's talk about the second one. 66% of these ASICs and 70% of the FPGA projects run behind schedule. So
Okay.
66% of, and this is an industry-wide research, 76% of the ASICs require 2 or more respins.
Okay.
And if you are doing a design at 28 nanometer, and if you're trying to go to 3 nanometer, which you would like to do if you're building small IoT devices, the cost of a mask for 3 nanometer is 25 times the cost of the 28 nanometer. So if you happen to be going down the 3 nanometer path and you end up having to respin, just imagine the cost. And you know what? The root cause of functional flaws in ASICs due to design errors is 60%. And the biggest contributor to the bug space is logic bugs, something that Formal could catch very easily. 62% of the bugs that industry is catching in their ASICs are down to logic bugs. And how many verification engineers do this work? Since 2012, 145% increase in verification engineers. So if you look at it, it's very expensive. So if you have Verilog, you have VHDL, you can write them very
Mm.
easily. In an open source era, it's even easier to write. But just turning this Verilog and VHDL into silicon that works always as intended, and you don't get sued in the field or you don't cause accidents, right? Like the famous Intel FDiv bug,
Yes.
right?
Yep.
You're going to be actually um, really struggling. So my take on this is, despite the astronomical increase in verification resources, we are still unable to avoid respins. We are still running behind schedule and spend most of the time focusing on writing and running simulation test cases, which this report talks about. So why on earth would you not take a step back and say, are we actually doing what we can do? And I'm not saying just do formal alone. In fact, we should do the both.
Yeah.
The techniques should be combined in a sensible way. And a lot of my customers actually already do that, and people understand that this has to be done.
A quick word from today's episode sponsor, Akenza.io. Guys, I speak to a lot of organizations wanting to develop their own smart solutions, and the common barriers that keep cropping up is complexity. This is why I'm so behind Akenza.io. Using their no-code self-service platform, companies can build great IoT products with value cases, connecting, controlling, managing and securing IoT devices, all in one place at speed and scale. Their unbiased technology makes it possible to register any type of device via any connectivity technology, process the data and make it available to any application in the cloud. The platform is adapted to organizations of all sizes, from startup to enterprise, from one device to massive IoT deployments. Thanks to the self-service solution, you can start creating your IoT case right away, even without coding skills. Akenza.io are offering an exclusive 30-day free trial, so you can test the platform out for yourself. Check out the link in the description and start building your smart solution today.
So this nicely leads me into one of the best practices, which is to combine formal and simulation in a sensible way. What we do is we write formal properties that could be used for verifying blocks, by which I mean it could be a load store unit of a processor, or it could be the whole processor, in fact. But now the processor is going to sit in conjunction with a memory subsystem. It may be driven by a GPU, it may be written by an AI/ML accelerator. And in any cases, whether you look at a load store unit or you look at the whole processor being driven by other IP components or by connected to the fabric, bus fabric, you're talking about doing the verification with formal with some assumptions, which we call assume properties constraints, but they need to be validated in the real world. And what I mean by real world is when these blocks are integrated with neighboring blocks. And most of the time, people again use test-based techniques. This is really a sweet spot. You bring one IP. Most of these IPs talk to each other via standard bus protocols. You can put a protocol checker in place, and you can actually verify the whole combination of these IPs in formal end-to-end. Now, in terms of deploying formal in the best possible way, what's actually the problem? Let's talk about the challenge first. On the one hand, people use a lot of these apps in formal tools that are called linting. Some of them even claim to do deadlocks. The low-hanging fruit, so you find an mismatched vectors, an overflow or an underflow. On the other hand, you do pin-to-pin connectivity checking, you do clock domain crossing checking. These are all done by apps, or you do an XPROP via an app. And most of these are turned towards the tape-out end. So formal, in 90% of the cases, is done at extremities. Most people don't even know that formal verification could be used throughout the full continuum, from the very first hour of writing the design code till the last minute you are about to tape out. And this continuum is what we are actually filling in with Axiomise. So what we are doing is we're walking into customer accounts where we are saying, look, give us your design blocks that are very hard, simulation resistant bugs. And we will make sure we flush out all the bugs and prove that they don't exist in your block. You can then take our properties on the interfaces, regress them in simulation. So you make sure that our properties are not making any invalid assumptions. Because what happens is we start with specifications on day one. By the time simulation is done, it's 6 months later. Some of these specifications may have changed. So it's not necessarily that we have made a mistake, but semantics change, expectations change. So unreachable code coverage is another area where actually, some of the code in simulation is unreachable. People use formal to do a proof that some of this code is truly unreachable.
Yeah.
But in order to do all of this, it's one thing to have a vision. In order to accomplish this vision, what you really need is to have a team that is well trained in problem solving.
Okay.
And if you're not good at problem solving, if you're not good at solving puzzles, if you do not know the domain knowledge, my team is verifying network on chips, big NOC designs. We're verifying cache coherent designs. We're verifying GPU blocks. We're verifying Ethernet routing designs. We spend time in understanding what the underlying domain is, architecturally and microarchitecturally. And this helps us understand the scope of verification and design. And it is a delta overhead on the project schedules, and we do have to work a lot harder. But if I am here to audit you, I better know exactly what you are all about.
Yeah.
I can't make an audit on you with half-baked information, right? So a lot of this is common sense, right? You would
Yeah.
imagine that, this ought to be clearer, but unfortunately it is not. We regularly deal with customers where they have issues with their previous generation of designs, they've missed bugs, and we come along and say, okay, why did it get missed? Was it because they made an assumption? Did they lack knowledge about the domain? Did they not write the right test case, never mind formal? And in a lot of it's a combination of things.
Yeah.
So just having more hands on the deck and putting more and more people writing code is not the solution. As I can tell you, with formal, less is more.
Okay.
The less lines of code you write, the cleverer the algorithm would be, the easier it will be for us to review. And I can guarantee you that we can verify massively big chunks of designs with 20, 30 lines of code in one place. So it's all about doing things in a clever way,
Yeah.
if I may use that word,
No, I think you're spot on. So I think it's about just making sure you're doing things like you said, in the correct manner and using the correct tools. I want to make sure that we turn over every stone for particularly for the audience. So we get a lot of IoT minds, a lot of my IoT heads watching.
Mm.
Is there any specific examples or use cases that jump out to you in terms of how formal has helped
Mhm.
in the IoT space or an IoT device
Yeah,
particularly?
right. So IoT devices are special in some way because they are small. They're usually made up of embedded chips. They often need to run on battery, so they have to be power efficient. A lot of these are actually processing data as well.
Yeah.
So security, trusts, I wouldn't say zones, because that's an ARM copyright, but trust areas are important. But security, power, and being able to design what you want to build in terms of functionality in a small area
Yeah.
is critical. So, by the way, if you're using an IoT device in smart sensors in monitoring health, you also need them to be safe. So functional safety then becomes important too, which, by the way, is mostly tied to automotive. People don't think of it in terms of IoT.
Yeah.
But actually, if you now look at safety, security, power area, they're already the four most important, actually, concerns for verification. Never mind that functionally the chip has to do the right thing. And if you look at what things can go wrong, so for example, what happens if you have a deadlock? So if it's a mobile or if it's a laptop, we see they get reset or some apps crash. It's not a big problem. You can always restart
Turn
things.
it off and on again.
Yeah, but with chips that are actually in the field tracking, monitoring, I mean, there could be surveillance chips, right? You
Yeah.
may not want that to fail in the field. Health monitoring. Uh, you just want them to work correctly. And you know what? All of the IoT stack, whether you're talking about a processor or its connected chipset, peripherals, analog digital sensors, everything is possible to verify exhaustively with formal. I've actually done work with a company. They were building these sensors for health monitoring for another customer of theirs. And we could blast out a whole lot of work exhaustively with formal within a few months, something they could have never done with simulation. They accepted it too. I mean, just imagine that you want to make sure that you're so let's talk about low power. One of
Yeah.
the things
Okay.
designers use is clock gating to save power, to switch off stuff. Now when you do clock gating, you bring in glitches, you bring in misconnected clocks, you have problems with the clock domain crossing because you now have multiple clocks that are actually being driven by each other. There's a fast clock, there's a slow clock. You've got asynchronous FIFOs in there. So what might appear like a not a particularly challenging design domain because you think, oh, it's a small chip, it's only going to go in IoT, you'll suddenly be fighting with multiple different
Yeah.
challenges. And they're not that different for a non IoT segment either. But it's just that for IoT, they need to be done definitely with formal, I would say. I
Yeah.
do not say, because I'll tell you this because we've deployed formal on these small form factor processors, and we have found bugs in these processors that are already in silicon. We found deadlocks. They've been verified previously with simulation. Some of them have even been verified with formal by some other groups.
Yeah.
Um, and what might appear as a very well done verification work might surprise you. So I would say look out for those characteristics of the design. And where we come in is actually making sure that not only does your base processor or a peripheral works correctly, but we are in it for end-to-end verification. The whole quantum of the core and the bus and the peripheral is all working correctly, because you can't just do it in parts and say I'm done.
Yeah.
So you see what I'm saying?
Yeah. No, absolutely. I think it's the key, right? I think because it's with the IoT, inevitably everything's connected. So I think you touched on it. One bug can cause quite a significant amount of problems,
Yeah,
and if
I
it's
mean,
not,
we know the famous ones, right? We know the famous Intel FDiv. We know the meltdown in the Spectre. And by the way, these bugs, when they are found, they're not in chips built by a small venture capitalist funded
yeah,
company. They are in the likes of Intel's, right? The AMD's, the ARM's, right?
yeah,
Not because these companies don't know what they're doing. That's because these problems are very hard.
yeah,
They have teams of experts already looking at it, but there's just so much complexity to the requirement space, and you're trying to make low area, low power, highly efficient in terms of performance. You want it to be the fastest chip. You want it to also work nicely with AI/ML, um, but you also want this to drive a car. So you suddenly want to do this work on compliance with ISO 26262, or if it's going in an avionics, a DO 254 compliance check.
yeah,
So now these compliance requirements add more work. So more work is coming on the stack, and unless we become efficient in how we handle it, we will always continue being late to the
yeah.
market, or causing more respins, right?
Yeah, absolutely. I mean, that sentence is perfect for where I want to go next. So you mentioned it's coming, or um, I think there's quite a bright future in this. So let's talk about the future and where we see a formal verification going.
Mhm. Mhm.
There's things that we haven't even talked about yet that are up and coming buzzwords. Everyone loves a buzzword in tech. So things like Risk V.
Yeah.
So there's quite a lot happening. So what do you see as the future for
So
formal at the
I'm
moment?
glad you brought up RISC-V, because RISC-V is one of the things that is literally changing the world today. Because of the open source architecture, anyone, literally anyone, a 13-year-old can build a RISC-V processor, whether or not they want to do anything with it or just as a hobby is another matter.
Yeah,
The challenge remains that verification is not easy, because
yeah,
as much as the Intels and the IBMs in the 70s and 80s were dominating the processor landscape, and now ARM and the companies like Imagination, or the other IP companies, they've got big teams of people doing it, right? But when it comes to a technology which is grown by the community, the RISC-V standards are open, anybody can participate. But when it comes to building a chip that is RISC-V powered, that is going to be deployed in the field, it's going to be really hard. And this is where Formal shines nicely. So we built an app which basically can take any processor core, and we can take that design into the app, and we can set it up with very little effort, with a few push of the buttons. And this app can automatically verify that the processor behaves like a RISC-V processor. So we have formalized the RISC-V specifications as formal properties. And the beauty of our solution is that it can be done using any formal tool from any vendor. So you can use a Cadence Jasper Gold, or Synopsys VC Formal, Mentor's Prop Check, or OneSpin tool. You take your pick. We are not tying you down into any particular vendor either. And what happens is we are able to prove that exhaustively this instruction compliance will work. The add instructions, the add immediate, the load, the stores, your cache coherency checks. Um, a lot of this can be proven to work without constraining the space of, oh, I'm only going to run one test. No, we run an infinite number of tests, and we can verify that these work correctly. So, where I see Formal going next is more and more custom domains would benefit or require that. Actually, why can't we do an app based verification work? And it's not easy. I've been building this app for the last 3-4 years. We've learned what works, what doesn't work. We've been testing it. Um, But if you go to a new domain and you're looking at, extending the scope of formal, there are multiple things that can happen. Either you build your teams in a way that they know how to do this in a scalable way, in a repeatable way, in an automated way, or you work with an independent provider such as us, where we, naturally are good at it because that's what we do and we've been doing it. Now, apps are not new to formal. In fact, they've been around for more than a decade, and they're widely used for solving bespoke problems. But those problems that they're solving, like it's a lint or a connectivity checking, very valuable problems. But a lot of the people call them boring because everybody knows what to do with them, and
Yeah.
they solve a rather well-defined niche of requirements. Processor verification, or I don't know, GPU verification, or you talk about verifying a subset of the networking IP, these are actually big functional verification challenges. Because imagine if you were an ARM or an Intel or an AMD, you spend a few $1 million building your verification teams.
Yeah.
Apple is renowned in the world for their quality of hardware, and the products that they build. And they're not building it in a rush, right? They've spent years building teams
Yeah.
that know what they're doing. So, and they, like any other company, they've invested heavily in formal, and most big companies are doing it, but unfortunately, it's still limited to only a handful of these companies. So where
Yeah.
formal needs to go is to make it completely normal, democratic, so that anyone can actually get the results, and not get bogged down with myths. That's what the problem is. So
Do
that's
you think
that.
that'll happen?
I think it's happening, not at the pace that I would like, but I'm generally an impatient person. So for me, everything needs to happen today. So my team will tell you that. But it's it is picking up, and I'm
Yeah.
not the only person making that difference. I'll be honest about that. There are other players like the EDA guys. They are trying to develop better tools. They're building better solvers. In fact, they are also helping us become more effective in the
Hmm.
field. So
Okay.
we excel at methodology. We excel at taking a big design and coming up with a test bench that can deliver the results. But we also need the tools to deliver, because we don't build those formal verification tools. But I think where it won't work very well, where I see challenges, is you have the usual inertia, right? Uh, because imagine if you've been doing something for 3 decades, why would you change?
Yeah.
Even if you have to change, the cost of the change may be significant. To be honest, this particular year, very hard for all of us economically. The world is going through a depression, but actually, it's not so bad if you think of it for formal,
Yeah.
because a lot of these companies are noticing where the efficiency is coming from, and they're continuing to invest in hiring more formal engineers themselves. They're coming to us to say, can we help them? So despite all the doom and gloom, and I think sometimes it's your hardest times that teach you how to improve and how to become better. And I think for that one reason, I think this year may be a good year overall for formal, because companies may suddenly realize that the amount of money they're burning away in not achieving much may not be worth it. I certainly hope so. And I do notice a trend. Whether it will happen in the next 5 years and how much of it would happen, I don't have a crystal ball, so I can't
Be good
tell
if we
you.
did, right?
But talk to me in a couple of years, I may be able to tell you more.
Well, there's a question at the end with you'll be able to touch on that. So I think listening to yourself, Ashish, what I'm learning is formal is quite agile and quite adaptive. To be fair,
Yeah, that's right.
and with the world that we work in, the technology and all that sort of stuff is ever changing. Everything every day, something's different, something's
Hmm.
growing, something's
Hmm.
evolved, and I
Yeah,
think that's where formal might become quite good, because there's things like, if you look at, I don't know, quantum computing, for instance,
yeah,
comes to mind, and how, again, a lot of the companies, because we do a lot of work in security as well,
correct.
and everything seems to be at a cost, or like
Hmm.
you said, well, what we're doing at the moment works fine. It's just like, yeah, okay, but you're gonna come against something that's quite a headache,
Yeah,
that you could have planned for 2-3 years ago,
that's it.
but now you're going to have to pay the consequences and the money
That's
that
it.
you've lost in that 3 years
That's it.
plus now. So I think it's just a case of people understanding the consequences of what might be. It rather
I
than
really
now.
do hope. I really do hope that we don't have a catastrophic event, which then happens because somebody forgot to do something simple 5 years ago during a design cycle phase.
Yeah,
Because I'm being honest, I do have worries. These days, the cars have so much electronics and
yeah,
software. It's crazy that they tend to know more about how we should drive than than us. And maybe in many cases, it is good because driverless cars may really know
yeah,
what to do in terms of active collision avoidance and whatnot. But no particular vendor makes everything. And that's where things get very hard because you may have 90% of the system thoroughly verified, but that last 10% that you're integrating may come from suppliers that may or may not have done the due diligence. And I'm not talking about paperwork for compliance, I'm talking about actually doing the work and not just a tick box. So, that is the scary bit because it's not that if you monopolize on 5 to 10 main vendors in the world who build everything for the rest of the world. No, in fact, with RISC-V coming, it's the converse. You now have more suppliers, not less, and more things have to talk to each other. So heterogeneous systems architecture work that was happening previously was predominantly about how you bring in ARM chips along with an x86 chip, this, but now you're talking about a RISC-V chip, talking to an ARM architecture
yeah,
chip, the x86 on a high performance 5G, 6G powered node mounted on a pole somewhere, doing AI based computations.
yeah,
uh, I think what I really like is the creativity, human creativity in terms of where we can go building these cool products is amazing. Just imagine what we can do just with the phones these days and what we were doing with the phones when mobile phones came out. Mobile
yeah,
phones, when they came out, seemed like a big deal to us, right? But look at what we're able to do: shoot 4K videos,
yeah,
do whatever, right? It's a full on computer. And if you now look at where active health monitoring is going, right?
yeah,
The fact that you can monitor your blood sugar with a device mounted on your body that can communicate to the app, that can call a doctor, or a lot of the health app features like you fall down and the app detects it. I just figured out as an IoT sock
yep,
that you can have as an elderly, and that sock, if you were to
yeah,
fall down, would send messages. And a lot of these are nice product ideas, but they need to work safely, you know both in terms of digital correctness, but also analog digital. You don't want batteries causing problems. You don't want
yeah,
chips to be consuming so much power that you end up causing it to become too hot and you burn the skin. There's so many things to consider. I'm not saying formal is going to be the answer for everything, but having a excuse me, having a clear mind
yeah,
in terms of what we are building, then doing the due diligence of verifying that these things have been properly implemented in the underlying hardware and software. That is what we owe to the community. We're
yeah,
not being honest if we can get away
yeah,
by building and making money. We have to say hand on heart, we have done everything we could. Right now, I don't think the industry can say that. And all they would come up with is a bunch of excuses for not doing something obvious. And I've had my share of listening on the other side about why they wouldn't do the right thing. And I regularly come across customer accounts, big companies, where one team is very favorably looking at Formal and the other team is saying, we don't need you
yeah,
because we've been doing, because you're literally walking into the den, right? And
yeah,
you're perceived as a threat rather than as a friend who can actually come and show you something better can be done. And I try and minimize the threat perception, but we work with human beings and it's just human, right?
yeah.
So,
Well, yeah, it links back to a lot of things. So I knew that, for instance, robotics. A lot of people out there or watching this will have some skepticism about robotics, and there's this whole analogy that they're going to take over people's jobs and all that sort of stuff. And a lot of the professionals
yeah,
that we speak to and a lot of people that we have on are like, no, it's quite the opposite. In fact, robotics are going to create more jobs, if anything.
yeah, absolutely,
So it's just
absolutely.
understanding
And
it, right?
you nailed it, and is exactly the right analogy. And I remember this robotics thing coming up when I was in school. Oh my God, everybody's, and I grew up in India. So this is a very high intensive labor force, right? Labor is cheap.
Yeah.
And it's like, oh, computers came in. Computers are going to make ticket reservations. Let's go on a strike.
Yeah.
Human beings have to do tickets, not a computer, right?
We're hearing
And
that a lot at the moment,
now,
aren't we?
yeah, I used to queue up on the railway stations trying to get my reservation done, and then it was the case of, oh, the computer never works. If it was paper, we could have done it. And nowadays, you sit at home, take a mobile out, you book your flights, you book your train tickets. It's a completely different world, and I don't see jobs going away. I just think the
No.
world is now operating at a different scale, and we are collectively aiming for that efficiency. And for formal, it can be exactly the same. You can build teams of engineers doing highly efficient formal verification, and then combining with simulation and emulation. Overall, the quality of the chip with the software would be amazing.
Yep.
But you really need a visionary in the semiconductor space, in the vendor system, guys who build these hardwares, to be able to say enough is enough. um, and that change is going to take some time, I believe, but it will come.
You've mentioned quite a lot of different sectors or whatever it might be. So let's take away. So at the end of the podcast, or when we start wrapping up, we start to delve into the people that we've got in front of us and what their backgrounds are and what they work in. So taking away the formal stuff, Ashish, what is your prediction for something in IoT for 2023? What are you expecting to either emerge really quickly or something
Yeah,
that we've already got within the IoT space becoming quite prominent away from
yeah.
formal?
So I think smart sensors for health monitoring
Okay.
and
Yeah.
security surveillance, these two areas I think are going to become more pronounced. I mean, notwithstanding the drone technology that already exists, but the drones are going to be used for not just wars and things like that, right? They're being used for you know taking photos of land areas, so they could then be used for land registry and making sure that everybody has an entry. For health, I already mentioned a few areas, but I think it's only going to become more and more dominant. What I would like to see is more providers and suppliers in the smart health
Yeah.
area, not just dominated by the big ones, just because it will give food for thought. I mean, just look at the sleep monitoring. The sleep
Yeah.
monitoring wasn't pioneered by one particular vendor, and people were able to come up and give you feedback on the quality of sleep. Now, does it even matter? If you're an average person not even able to make your ends meet, do you worry about the quality of sleep? Maybe not.
Yeah.
But for a number of elderly people, being able to monitor how much they sleep, and because sleep is a direct contributor towards health, this is starting to make waves. For diabetes, for other health issues, I think all of this is going to be more and more. It's not going to go away. And I think that's where not just 2023, I think the next few years would be going. um, I think the security surveillance is interesting. I would like these cameras and recognition systems, audio, video, to be more inclusive. I think right now they are kind of carrying the biases that society has, and unfortunately, the distinctions that they make in the quality of the audio or the video is not that intelligent. So I would imagine more AI and ML learning from the data would actually make these things more intelligent. So not just the fact that drone is acquiring an image and sending it over to a control center where a human being takes a decision. The drone should be able to make that decision with the data they have. And that's where low power would
Yeah.
become handy, right? Or solar powered drones or something. So I'm sure the guys who build these things are already onto it. We may not just know about it, right? So
Yeah.
that's where I see the world going.
There's lots of things happening in terms of low orbit satellites and
Yeah.
things like LoRaWAN and things like that. Yeah, so it's all up and coming.
Mm.
Okay, so again, not to put you on the spot or under pressure or anything, but we like to ask 5 quick fire questions.
All right.
So this could be anything. I've got a list in front of me, so I'm just going to pick random ones.
Okay.
Question number 1 is a quote that you live by, Ashish.
Oh, that's an interesting one. I'm not sure I remember any particular quote that I.
Is there a particular mantra that
I mean, my mantra is treat human beings with humanity and
perfect?
don't
Yeah.
think of anyone as being any less than you. And I tell you, this is really working in my favor because I work with very smart kids and they teach me a whole lot of stuff that it would take me months. Even working on vector graphics is a classic example, right?
Yeah.
So my son could teach me so much about vector graphics that it would take me literally a year to master. So
Good.
yeah, the next generation is the best generation. That's the
Hopefully.
mantra I could.
That leads next to I've picked this one specifically for what you've just said. So if you could learn any new skill, what would it be and why? Doesn't have to be tech related.
Yeah,
Anything that you could learn or
I
why?
would love to learn how to play a piano and a
Yeah.
saxophone. Both are very hard, but I love both of these instruments.
Any
So
particular reason,
yeah,
or is that just because like the music you listen to or whatever's
just the
got?
music, and I just think the things that you can do with these instruments.
Yeah.
And they're very different. I mean, okay, they're you know both wind-based instruments, but they both require different capacities. One
Yeah.
requires your lung capacity, and the other requires your fingers to be nimble. But yeah, I mean, being able to do that would be good. But yeah, it's
Yeah.
hard. I must say, I tried.
I think I know the answer to this question because you mentioned it a couple of times, but I'll ask it anyway. Actually, no, I'm going to reword it. So, outside of health sensing or medtech, what IoT trend would you like to see end? Actually, I'll change it. So, what would you like to see end in 2023? Not get better.
So, as I said, I'm a big believer of humanity and peace. So yeah, maybe we should use less IoT in war
Yeah,
technology,
that's a great answer.
and maybe use it for more constructive reasons. But that's the wish, anyways. Whether that would happen is another thing.
Great answer. Okay, two more. So, over your time and experience, Ashish, what has been the biggest tech fail that you've seen?
Yeah, that's a good one. Tech fail. I thought all of this .com boom that I was witnessing at the time, I think that was rather disappointing that it didn't turn out to be what it was intended to be. Um, that is the one that strikes out
Yeah,
as being the most visible because it came with a lot of hype, isn't it? I mean, people would say AIML is also not living up to the hype, but I wouldn't say that. I mean, that's the thing is people who create hype will know no ends to
yeah,
create that. But I would say AIML. I know a lot of the startups may not be able to survive the recession and so on, but the creativity that AIML has empowered, I think that's still driving everything around.
yeah.
So yeah, that one is
I
still
think
on.
we now live in a world of social media and money, so it's easy to hype something up, right? For it
Yeah,
to then not work, but then
yeah.
it's also just as easy to cover it up and hide it.
Oh,
Um,
talking about things that could actually be done less of, and then I would say maybe a lesser social media would be good too. especially
uh,
especially the ones where people spew hatred behind anonymity and
yeah,
are driving divides in societies. I think if we had less of it, previously, Brad, when you and I were growing up, we worked hard to achieve something. It was the passion of going after something.
yeah,
It was not about going in a podcast with you. That was the ambition,
yeah.
Uh, you
Why
could,
not? Should be.
you could of course be cheeky and say that I did Axiomise for to come in a podcast with you, but actually, and that could be, and you may be right, but the truth is that nowadays everything is about these reels that people make, right? And it's all
Yeah,
about how, in a way, it is good. You can see more people dancing and music and things like that, which is not such a bad thing. But yeah, it's the hate and the negativity that the social media is creating. Really wish that we can fix that problem. I just don't know if anyone can.
I think social media it does a lot of good, but I think it creates a lot of anxiety, a lot of body consciousness.
Mm.
Like
Yeah,
you said, we're growing up. To me, it was always climbing trees or playing football in the park, and
yeah,
now it's just social
absolutely.
media and technology, right? So it's
WhatsApp,
changed. Yeah,
WhatsApping, yeah.
yeah, exactly that. So that brings us to a wrap, Ashish. It's been an absolute pleasure. I think this is a hot topic
Same
at the
here.
moment,
Same
and
here.
I think it's only going to grow. Just to finalise, then, where can our audience find you? So if you can just give us your social medias
Yeah. So
or
talking about
Axiomize's
how bad
website.
yeah, talking about how not so good social
Yeah,
media is, I
where
would
can I
say
find
no,
you on
we
it?
are using social media too. So we are on LinkedIn, we are on Twitter, we are also on YouTube. I run a very successful YouTube channel which promotes education on formal related topics, but also verification. I was podcasting back in 2020 on these topics, And there are a lot of very, very clever people who were very kind to me, who came as a guest to my podcast. And a lot of these chats are highly educational.
Yeah.
And I would strongly recommend, if you're a student, to check it out. But yeah, come and talk to us. We are very friendly, lovely people, and we like to talk to everybody and anybody. We're very inclusive and very open. So
What's
yeah, let's have.
Axiomise's website, Ashish?
Oh, it's www.axiomise.com. So yeah, check
Perfect.
us out there, and yeah, drop us a line. Let's talk more formal. So
Absolutely. Right, let's wrap it up then. Ashish, give us your one key takeaway from our discussion today.
So I found this chat to be very insightful, coming from people who value IoT. So I quite like the fact that you approached us to drive this conversation, because a lot of our work currently is for high performance computing, for very
Yeah.
big chips, and because that's where people think you need more formal. But your invitation actually made me reflect a bit more on the relevance of formal for IoT. So yeah, thank you for driving this
No,
chat. I
it's fine.
enjoyed this very much, Brad. It's good.
Well, no, absolute pleasure. It's been a pleasure having you. I think mine is just the relevance of formal in everything, and how I think it's going to become something that, well, as you called it, formal is the normal, right? So
Yeah,
fingers crossed. But no, genuinely, it's an absolute pleasure to have you, and thank you so much.
same here,
I
man.
look forward
Thank you.
to speaking again in the future.
Yeah, thank you very much.
Before we go, I wanted to thank today's episode sponsor, Akenza.io. Don't forget to check out the link in the description and gain access to a 30-day free trial of their self-service platform.
Thank you for tuning into the IoT Podcast. Don't forget to subscribe on whatever platform you're on, and see you next week for more IoT talks and tales.